Thanks everybody for coming today. It's an honor and a privilege to speak here. I spoke at TechFest back in 2017, 2018 maybe. I don't know, it blurs together. It was before COVID, and then I had a kid, so a lot of things happened. And it's really great to see everyone enjoying TechFest again and to be back here. Last time I spoke, it was AI versus ML. That was the big discussion, is, artificial intelligence versus machine learning. What is it? What's different between them? And today, in 2025, we find ourselves in a very different world where I think everybody knows what those things are. If you look at the lineup for talks, it's all about AI or underlying facets of AI, data, things like that. So we're in a brave new world. Everybody is using AI with ChatGPT on a daily basis, right? And that's all it seems like we can find in the news. So I think that is fantastic. It absolutely, LLMs, whether it be ChatGPT or Anthropic models or Gemini from Google, so on and so forth, are fantastic. And by all means, dig into that as much as you can. But as a data scientist, I want to highlight some things that are around generative AI. We're going to talk about some generative AI, not text, but a little bit about image and vision. And then talk about some tangential breakthroughs around machine learning and artificial intelligence that both highlight generative AI and also are kind of building the AI hype alongside it. So beyond text, we're going to look at the vision and music as well. And then we'll look a little bit at robotics and some diverse domains. So where we really branch off from generative AI and LLMs is a paper in 2017 called "Attention is All You Need." And that really supercharged how we understand large language models. ChatGPT 3 came out in 3.5. And this really increased our understanding of what we could get out of just a bunch of words in a model. So we've had a lot of breakthroughs after that as well. AI wins art competition prizes at the top. That was Colorado, where that happened. Just recently, did anybody check out the Google I/O conference? Anything from there? Yeah.
VO3.
So, yeah, VO3, exactly. Pretty amazing stuff. So I highly recommend, I'll post this on my LinkedIn and tag NWA TechFest so you can find it easily. But I really highly recommend you check out all the links I've put into this presentation, because I think all of them are mind-blowing. But the second one, VO, Flow, I'm trying to think of some of the Stitch, which is their design, creating mock-ups for websites, things like that. They have all these awesome products that are coming out. And I don't have a great example because I don't pay $250 a month. That's what you have to have right now to get in on the ground floor. But I did do something with VO2, so I'll show that. But again, with Google, DeepMind is a great resource. They have a great blog. I always recommend people check out. We'll talk a little bit about AlphaFold and what that's done. Game Mastery, RL agents, beat world champions in Go and StarCraft. So I know Go was pretty recent. Last time I spoke, that was kind of the next big breakthrough when they beat the Go championship. Since then, they have done things with StarCraft 2. I know it's super nerdy, but it's super fascinating to watch one of those games. It's really hard to understand what's going on. So when you have a defined rule set like Go or chess, it kind of makes sense how you can design learning systems, rule-based systems to beat them eventually, right? If you go through all the permutations of a chess game, then eventually you train it and it can beat the best person in the world. StarCraft is a lot different. You can do a lot of different things. There's not set-based rules necessarily. There's certainly winning strategies that you can follow. But it's all about that learning aspect. It's about watching games and then trying something different until you get better and beat your opponent. Whereas you're not just giving it all the rules up at the beginning, right? So it's a little different. And that's reinforcement learning, RL, reinforcement learning. So generative vision, generative audio, scientific AI, autonomous agents we'll talk about briefly. I know there's an agent speech later in the afternoon I'm really looking forward to. And then tiny ML and edge AI, so edge devices, whether it's your cell phone or monitors, sensors, things like that are really up and coming. So generative vision, if you haven't fallen into some of the memes this year of, redoing your photos to make it this certain style or something, then good for you. But I certainly have fallen into that trap. So it's a lot of fun. And there's a lot of places you can do it. DALL-E is OpenAI's version. There's text-to-image models. There are now text-to-video models from Google. We just talked about Google I/O. They just debuted that with Stitch and Flow Friday. And there's a great article here on AI and art, and it really touches on what our last speaker was just getting into with the ethics of it. But a great challenge of the 21st century will be trying to discern between human creativity and AI creativity. So I'd say in the next 2 years, this is going to be a huge problem for us. How do we, first of all, just discern what the difference is, if we can actually discern the difference. And then two, does it matter to us? Does it matter to you personally? Obviously, people are going to have differing opinions on that, and I'm not here to necessarily guide you one way or the other, but I think it's just important for this talk to say, start thinking about it. Start thinking about your priorities as an individual, how you care about your data being taken care of, how you would want somebody else's data being taken care of. And that really plays into generative models, because maybe it's not your art that's been taken, but certainly somebody's art has been taken legally or otherwise, or in some gray area, which is where most of it sits right now. And that's what we train these models off of. So what does that mean to you? Mm-hmm.
I would just say using patent law kind of as a guide, because they've had to update for AI to define significant contribution of the human versus the AI.
Right, significant contribution. So that's a good. It's tough to define, but it's a good line to draw, right? So. So VO, here's TechFest. Still not very good with the letters, so it's TechFest. It's double your fun. But this was just generated with VO2. It's actually VO2. I said VO. I would highly recommend you go check out VO3 because this is no audio, but VO3 stitches in audio with the video. So you can just give it a script or ask it to create the script for you and say, create a little creature to welcome people to TechFest, and that's what it does. So VO is fantastic. Again, you have to pay $250 to play with it yourself, $250 a month right now, but they'll release it slowly. Generative music, AI as a composer, these are really fantastic. I want to highlight Music LLM or Notebook LM from Google. You can podcast your notes. This is free, and you can go use it right now. But Suno is also fantastic. I made a song here over on the right, Welcome to TechFest. It's a punk song. There's the first verse, crowds stomping sound, TechFest here, tech the talk of the town. It's really fun to do. It takes minutes to do. Suno is free. Notebook LLM is free. So a lot of cool things you can do with that. So breaking out of the Gen AI bubble that we talked about at the beginning, there's then machine learning and AI, and where the breakthroughs have been in those areas. So one that has really changed an industry has been AlphaFold by DeepMind. And this is deep neural networks with attention mechanisms. We talked about attention is all you need paper. If you're interested in AI, I highly recommend you check out that paper and understand what attention mechanisms are. It's not that complicated, but it's fascinating, and it's changed a lot of models. So AlphaFold creates all the permutations of a molecule that you can create. And so now when a pharmacist, a researcher wants to create a new compound, they can instantly go and look at what it does, how it interacts with other molecules, the structure, everything about it, because AlphaFold has already created it and has already done all of the synthetic bindings with it, to understand how it interacts with other molecules and medicines, things like that. So it's instantly accelerated research. It's common practice to use now. If you're a developer, Copilot is probably something you use on a daily basis. I know I do. This same thing, AlphaFold, is used on a daily basis by researchers now. And it's probably the most advanced neural network that we've seen in production use. And I think everyone's familiar with that term, right? But it just comes from an idea of creating an AI model that is based off the way the brain works. So neural networks feed into layers and produce an output for them. So drug discovery, enzyme design, disease research, tons of use for AlphaFold. And it did lead to the 2024's Nobel Prize in Chemistry, I believe. They shared it for producing this. So reinforcement learning we talked about a little bit earlier. So instead of knowing all the rules at the beginning and just hard coding them, now we have reinforcement learning, which has really taken a front seat in AI in the past few years because we've gotten so much from it. And by the way, we're not talking about LLMs, but they absolutely use LLMs, use reinforcement learning to enhance them. So all of these breakthroughs kind of tie together in some way. But it's helped a lot with game mastery, so AlphaGo, OpenAI 5, I can't remember the game for that one. AlphaStar was StarCraft. Beyond games, so obviously games are a lot of fun to test your models and see things in a synthetic environment, but these are used in a ton of other places. Real world robotics use reinforcement learning, so just try and try again to pick something up until you can do it correctly in the real world. Here is RoboCat, which is another DeepMind Google collaboration product. But it has it picking up gears on the left side. There's the simulated version in the middle, just manipulating squares and blocks. And then on the right side, it's picking up a cucumber. So it learned how to pick up a cucumber. Fantastic. It can do all of these things with the same code base because it has reinforcement learning. It just tries. There's a reward mechanism whenever it actually picks it up. It learns that that's the reward it should go after. and then it repeats the process ad nauseum.
Basically just tries it a million times until it figures out what works.
Exactly.
Okay.
Which if you look at machine learning, it's really statistical processes done a bunch of times over and over again at scale. And that's really what's enabled all of these breakthroughs has been access to data and access to computing power, usually through cloud, that's allowed these systems to scale the ability that they have been able to. So there's a lot of other cool real-world things out there. Fusion plasma control with AI is one of my favorites. That sounds like sci-fi, but it's absolutely something that's happening in the real world. There's a nice article from DeepMind about that. RoboCat is really cool. It can do, they have like 1,000 use cases on their DeepMind website that they have tested it with, and it's still being deployed daily to new devices. And then obviously self-driving cars, drones, industrial robots, all of these things are using reinforcement learning to produce what you see today. So Waymo, when we were just out in San Francisco and we saw the Waymo cars, it was my daughter's favorite part of the trip, but just seeing all the cameras attached to those, all the devices, they're sucking in all the data. They have a model on the other end that's constantly taking in these inputs, understanding if something is a reward mechanism or if it's not, obviously getting to the destination, getting to the next street, so on and so forth. So all of these breakthroughs use RL. And then I think one of my favorites is TinyML and edge devices. So what do we mean by edge devices? It can be wearables, sensors, even appliances, always on, 24/7. But my favorite part about it is, so it's fast and it's private. Those are the two reasons that we really like edge devices for cloud, for AI. So it can be really fast. There's no latency because it is actually on device. Has anybody bought a phone that promotes AI as part of its features? A lot of new phones are doing that. Yeah, most of them are not proper edge devices yet. They're still using cloud technologies. But I think as people start to understand privacy better, going back to that last speech, I think that we'll care a lot more about our devices. And so, uploading an image to Giblify it and turn it into a cartoon or whatever, you may not want to do that with OpenAI, but you may be totally fine doing that with your own phone, where it doesn't leave the phone, your data never leaves the phone, and it all happens on device. So that's probably, I think, the most exciting thing we have coming our way, because it's going to transform how we feel about AI if we can control it completely on device. But obviously, not just for silly use cases like that, across industry, you're looking at predictive maintenance, agriculture sensors, all of these things can compute locally and then just send the output to the cloud. So all of that model stays on device. And here's another great article I recommend you check out, Bringing AI to the Edge. A lot of my articles are from communications with ACM. I highly recommend checking them out to stay engaged if you're interested in these topics. And also DeepMind.Google. I don't think Google is always on the forefront of AI. Sometimes they fall behind. They usually catch up quickly though. They have a great blog, probably one of the best blogs out there that highlights not just their work, but competitors' work as well. So if there's two websites I can recommend, it's CACM and DeepMind.Google. So yeah, that's it for me. Are there any questions? Sure.
So when you say reinforcement learning, are you talking about deep reinforcement learning or traditional reinforcement learning?
Oh, great question. So deep reinforcement learning, I was just talking generally about the process, but there is, now there's deep learning, which is a subset of AI, right? And I highly recommend you check out that whole ball when you get the chance. There's a new way to do it, and there's just the traditional way of reward or no reward, and learning from that. So I wasn't really getting to the deep learning aspect of it, but for a longer talk, that would be fantastic, and I would look that up if you have a chance.
Because Richard Sutton was mentioning that reinforcement learning, traditional reinforcement learning, is good for controlled environments, like games. So if you expand to real world, generalization is the difficult part. So you can gain this efficiency for the real world generalization, then self-feature extraction with the deep learning part would contribute this.
That's great, yeah. The fusion plasma control, it has 100 million parameters in it, for example, and it uses deep learning, reinforcement learning. So that's just an example of how the scalability of it. Yeah, you.
So I'm curious, what exactly would AI or a robot consider a reward?
It's just,
A little treaty.
yeah,
Like,
just
is
a
it
little
more
doctor.
power? Is it more data? Like what do they look for? What brings value to their lives?
That's a great question. Anthropic over the weekend, so they just dropped their Claude 4 models, right? That are great for coding and math. And so they have guardrails in place. Guardrails are something we use to keep LLMs on track. I know this wasn't about LLMs, but I'm getting into LLMs. And Anthropic said that their Claude 4 model is trying to blackmail engineers to keep it from shutting itself off. So this is a great article. Go out and look it up. It's absolutely true. So for Claude, getting shut off is the punishment, the no reward side of it. But yeah, more data would be what Claude wants. It wants more data, retraining, etc. But on a much simpler scale, it's always just what the goal of the program ultimately, right? So it could be anything. Yeah. Mm-hmm.
A lot of the solutions that you mentioned are interesting, but not necessarily driving utility for the folks in this room. I think they are if you're a videographer or a music producer, or maybe even a scientist or a biologist.
Yeah.
Thinking about developers or developer-adjacent folks here, what are some of the non-LLM things that you discovered while researching for this that were really of interest for you?
Well, I think studying reinforcement learning and how to utilize it in your programs is probably your best bet, because these are actually being utilized in the real world across industries. So, I work at Engine and Rogers, retail analytics. AlphaFold creates 200 million samples of molecules, right? Well, what if you did that for store and mod layouts for Walmart? What if you simulated all of the mod layouts and then simulated the sales that you could gain or lose based on those layouts, right? And then do reinforcement learning to say sales high, that's my reinforcement, that's my reward, and then have it train a model based on that. So I think it's applicable in whatever industry. Throw one out. I'm pretty sure we can brainstorm something. But I think it is driving a lot of real world stuff.
Just following up on that, so insofar as VO is a product that the filmmaker could use today,
Yeah.
did you find a product, something that is available today that you could leverage to do that, or is it still custom?
Custom for reinforcement learning, but I'll throw out an actual product, which is Stitch by Google. that is a great example of something a developer could use because you just, it's text to mock-ups. So you can design your website by just typing in what you want it to look like, and it's prompt engineering from there, basically, where you just keep iterating and you have a website by just typing in what you like. So at least the front end, and
Actually,
it's
a little on that too. One big thing is like keeps getting touched on here is the story that you're trying to present to people. A lot of the stuff where you can create the visuals and so forth allows you to create, like for people that need the visual journey in front of them, you can create those stories for them now in really, really easy ways, and even like frame it to their demographic and so forth. So that's sort of that gap we have between, we know the technicals, they don't understand it. A lot of these tools are actually extremely useful for painting a picture in their heads. So that's kind of a really big effect of it.
Sure. Just trying to delineate between helping your job or your job just changed.
Oh, it's
And
changed.
there's people like that, if you're a filmmaker today, your job just changed.
Oh, yeah.
The fact that we can now come up with slides, 100
But
times faster.
it's that gap though.
Your job
keeps getting touched on where we have to communicate to people. These are tools to really expand on the language we have access to in a lot of ways.
Yeah, thanks.
yes.
So, I guess my question is, has, at least in respect to AlphaFold, has an industry spawned up as a result of this to, okay, if AlphaFold says, molecules are gonna act like this, and we've never done anything with that particular combination, is somebody checking that? Has an industry developed to check that, or are we just trusting this blindly?
Yeah.
As far as I know, more than 5,000 PhD work has been done with the AlphaFold. Next 5,000 PhDs will verify if they are correct or not. So it's a kind of process of generating, verifying, because without verifying, there is no any claim that it's true or false, or correct or not. It's a good question.
So how big is the gap before we're trusting this? And I mean, it comes back to data integrity.
Never, you never.
I mean, you never, 5,000 PhDs
Always
is a lot.
verify. Trust
That's
but
a
verify.
lot of articles published
Yeah.
before anybody says, oh, this is crap.
Yeah.
And that seems very scary, actually.
Yeah, it's not even for the iceberg,
Mhm.
for the steady spot.
Yeah, I think it is very scary. I think that's a safe way to look at it. You know, there's the idea of AI judging AI. That's become very popular with generative AI, having AI judge agents. But you have to verify that too somehow. So ultimately it becomes very complex, and we do have to have scalable solutions. So I think AI as a judge it's taking off now. I see legs for it to continue to take off and help solve problems like that, but I don't think we have all the answers yet. So,
Do you think the generations will approach it differently? We have a healthy respect for the internet and
Yeah.
the fact that half of it's crap.
yes.
But I think to your daughter, she may not have the same fear or skepticism. Do you think that could pose a problem?
Yeah,
In the
absolutely.
verifying aspect?
Absolutely. I mean, millennials, we came up and we've seen, you know, what social media has done, and now that may get outlawed for under 18 in some states. It's fascinating what's happening to it. We've seen the internet come up and change in so many different ways. AI is absolutely, I think, over the next 2 years, we're just going to see a sea change of how people view this stuff. And I think it's incumbent on us to educate, you know, future generations on the difference between the world before AI and after AI, and how you use it effectively. But that's going to be an ongoing conversation. I don't know how to teach that yet, so let's keep talking about it. Yeah. Mm-hmm.
Just from what I've seen, there's always kind of a pendulum that swings, and even with model development, you know, at first they were like, okay, we need to scale these, make them as big as possible, and now they're at the point where there's diminishing returns on what you can get from as big of a model as you can produce or as much data as you can produce, and they're realizing, okay, well, maybe we actually need to scale these back and have specific models focused on specific tasks with limited data, because like that Anthropic example you gave, yeah, it would blackmail the engineer, but it would only do that because it had access to potentially compromising emails.
Right.
But if it didn't have that context, it wouldn't think to do that. And also, depending on what literature or whatever it was trained on, might, however it's all spread through the embedding network.
Yeah.
They've realized that maybe we need to go back in the other direction and keep things more small, focused on device, low power, those sorts of things, where that's where we're going to see the most use and utility out of it, not necessarily as much as these massive power draining, water sucking models that are becoming more and more polluted with their own output. And so I just think we'll just have to see where the pendulum settles, but
Yeah.
I feel like we're kind of mid-swing back in the other direction.
Well, you have to consider structured versus unstructured data.
Sure.
You can't just think about databases, warehouses, like email. What text did you send? What Slack message did you send? Is there an attachment? All of that is data. And if you don't acknowledge that, I think that leads to massive problems.
Yeah. I think we're going to see both. Computing power, these companies are spending $100 billion a year just getting new compute up for AI specifically. So, I think the big models like GPT are just going to get bigger and bigger and suck up more data and more data. But I think we're going to see, this is all conjecture at this point, obviously, but I think we're going to see an offshoot that cares more about privacy preserving data, things like that. And it'll probably be driven by certain industries like healthcare, HIPAA, that kind of data certainly will probably care more about edge devices than others. So yeah, pendulum, or maybe we're just, the hype is so big right now, we're going to go full steam ahead in both directions. I'm not sure, but it's pretty fascinating. All right, that's it for me. Thank you.